Hi, my name is Dominick Romano, and I'm the founder of Drainpipe.io. I'd like to welcome you to the World AI Con Festival 2023. Today we're going to be speaking about using synthetic environments to train artificial intelligence. So as events occur along a manufacturing process, we must collect information gained in order to extract value and intervene in the progression of time. This allows us to save time and money in preparedness of faults, failure, and costly downtime in the manufacturing process. See, in manufacturing facilities, events are occurring all the time, and it's important that we capture these events and generate data sets in order to extract value from them and respond to new events as they occur. So in order to do this and to capture the full situation within a manufacturing facility, we have to work with many different types of data. And today we're going to touch on 4 different types of heterogeneity. Syntactical, which is data with the same source but different descriptors. Semantic, which is data that has modeling differences but within the same domain. Ontological, which is variations in naming the same entities but from different sources. And pragmatic, which is data that has differing human interpretation, but it's the same underlying data. See, as all of this information comes together into one database, it's important to be able to capture the raw data and the various forms of multimedia that get generated as a result. In a manufacturing facility, you may have logs that are generated from manufacturing equipment. You have events occurring all the time. You may have alpha text records, which are those are your quantities. You may have audio, which is being generated from your machinery. You may have transcripts of staff communications. You may have video, which is watching the manufacturing line. Imagery, which is being generated from the manufacturing process, potential faults, maybe mislabelings. And as all of this is occurring and all the events are occurring within a manufacturing facility, we want to track entities as they move from one stage to the next so that we can develop a bigger picture and a better understanding of what's occurring in a facility. Now, when you're tracking large, diverse raw data sets, there are 2 main types of data sets that we're going to focus on: quantitative and qualitative. Quantitative are data sets that rely on large amounts of data in order to extract value, and qualitative are focused, domain-specific data sets that allow us to extract value without having to amass a large amount of data to support it. Now, in order to connect all of the diverse raw data that is generated within a manufacturing facility, we need to go through several phases of representation in order to extract value. So we start off with diverse raw data coming into a system. Then we need to unify the representation of that raw data in order to standardize it and do something with it to extract value. Then from there, that data is aggregated, and through the aggregation process, it becomes situationally localized, allowing us to identify emerging trends within large data sets. This is useful for when different events occur in a manufacturing facility and we amass large data sets. We can hone in on the specific events that are occurring that create trends, because as large data sets are amassed and we're able to look at the various trends and how each situation affects another, we can identify emerging trends and emerging situations to be able to better respond and react in the future. Now, in order to do this, we must unify our data and aggregate it. To do that, we have to standardize the information that we're working with. So to standardize information, we have to ask similar questions of it. So, what is the information? Where did it come from? When did it happen? Where did it happen? These are events that are common. These are questions that are common within the manufacturing process. So, when did an event happen? What was the event that occurred? What was the entity? What happened to it? Where did it come from? Good questions to ask of all data coming in. When you have a standardized set of questions that you're asking of data as it's coming into a system and you're defining within a system, you are able to then unify the representation and better identify the emergent trends that are contained within it. Now, as events are occurring in a manufacturing process, we're always identifying what a scenario is, what the situation is, what the performance is, and we're designing situational relationships and scenarios that would better enhance or would better drive outcomes within the manufacturing process. Then we validate the results of that design, and usually that's done with human intervention. After validating that our assumptions of a design were correct, we then move to the optimization phase, where we optimize the outcome to reach the desired results. After optimizing and reaching the desired results, it's then that we autonomously detect the identified scenarios that were designed and identified. Now, in order to do that with a feedback cycle, we have to work with the various forms of events and situations based off of the data that we have that occurred in the past. Sometimes situations occur that don't occur very frequently, leaving us with sparse data sets. However, when dealing with diverse data sets which may or may not have complete records of information, it's important to learn from it what we can to develop new information that can better enhance our understanding. See, data can be turned into information discovered by simulating even the slightest variations in sample sets. And simulation may also originate new data entirely. So as we collect information based off of what's happening, we're developing a past view of the events that occurred. And as we're doing that, we also are utilizing that data to better respond to the events that are coming in the future. And that's very important in the manufacturing process to drive preparedness for potential faults, potential downtime, potential outages, and to also always be identifying areas that can be optimized in order to drive productivity and in order to drive down cost that is incurred as a result of failures and waste. So how Drainpipe helps this problem is Drainpipe allows operators to simulate new scenarios and events that might not have occurred before in order to collect information from it and label the information that gets collected to then be able to train into artificial intelligence models which can be deployed into real-life situations within a manufacturing facility. So what we're able to do is simulate a manufacturing line, generate scenarios where on a manufacturing line the labeling is incorrect at times, or sometimes there's faulty labels applied to a product, and we can generate annotated data sets for those labeling faults so that when we're looking at the real manufacturing line in a facility with a camera, we can better detect when those faults are occurring, saving us money and also saving time that it takes to detect these situations occurring. Now we're going to jump into a demo of this process and show you exactly how this happens. But I invite you to stop by our booth at the World AI Con Festival. We're at booth A08, and we're also a proud sponsor of this year's event. Now let's get into the demo. So welcome to Drainpipe. I'd like to bring your attention to our homepage where we have some visual examples of Drainpipe's extraction of advanced multimedia. See, when you upload images and video to Drainpipe, Drainpipe will automatically extract the data points that are stored behind the scenes. Conventional systems make this difficult and don't allow for connecting these data points to other events nor training artificial intelligence models. But in Drainpipe, this is trivial, and you can easily visualize complex multimedia and its underlying structure, as well as utilize advanced analytics and train artificial intelligence with it. So let's go ahead and sign in and start our demonstration. So when you first sign into Drainpipe, you're brought to your organization's virtual data room. Now, in your virtual data room, you can manage all of your organization's day-to-day files. That includes IP, info regarding your team, material agreements, your corporate documentation, business plans and financials, your deal pipeline and CRM, patents, trademarks, NDAs, partner agreements, all of the crucial documents that make up an organization's day-to-day operations can be stored within your virtual data room. And all of your files are labeled so that the team members who need access to this sensitive information can have access to it securely. So we're going to go to our asset manager where we're going to create a new environment for manufacturing. We're going to call this environment My Line. And we are going to create a manufacturing line for aluminum cans where we're going to simulate labeling defects on the cans so we can generate synthetic data that gets re-ingested into Drainpipe to train artificial intelligence models for detecting these scenarios in real life. So let's save our changes and make our way into our manufacturing line. So here's our manufacturing line. And what's happening here is as cans are moving down the manufacturing process, we are labeling the cans, and in some cases, we are applying labeling defects so that we can train models to be able to identify these scenarios. So let's go ahead and click the camera button to record some examples for training an AI model. Okay, that should be enough. Now, as new data comes into Drainpipe, Drainpipe will determine whether or not it fits within a pre-existing definition. Now, if data can't be identified, Drainpipe will push your data into an artifact inbox. Now, in your artifact inbox, you can view data that has not been labeled before or that an AI model is highly uncertain of. Now, by being able to do that, you can label what this data is, and ingest it into the system. So here we're going to label some defect records. Okay, we're going to apply changes. Now we're going to build that class. Now that we built that class, that information is going to be visible here in our class directory. So let's go ahead and edit our class directory. What we're going to do is we're going to add a child to this defect label class, and that's going to be our manufacturing events. That's the recorded events that occurred within the manufacturing line. So there we go. We added our manufacturing events. Let's go ahead and view this now. So this is the structure of the data that we have now just connected. And this is what the training set looks like. We have an example of the actual manufacturing line, and we have a label that correlates to that image and tells us whether or not there is a defect present within that image. Okay, let's go back. What we're now going to do is we are going to train a model to be able to detect these defects. So what we're looking to do is we're looking to ingest an image first and then output the defect probability. So we have our manufacturing events, which correlates to the recorded imagery from our simulation, and we have our defect label, which correlates to the labeling of what occurred. So let's click Add Model. We're going to give that a second. And here we have our dyno report. So this dyno report is a report of all of the examples that were trained into a model, including the analytics associated to each of the examples that were trained. Now, from here, we can do a few other things. We can go to our Jobs and Events Manager, where we can see the various different jobs and events that have been running across our account and organization. So as images are uploaded, we can extract the metadata from those images, which is similar to the example that you saw on our homepage moments ago. And we can understand the duration that these events take to process. We also have advanced statistics and analytics where we're able to set custom ranges such as specific days, specific times, and specific time zones, as well as specific intervals being cumulative, hourly, daily, or monthly. We can specify which dimensions we would like to evaluate and view, and we can also select which metrics are most important for our report. Now, Drainpipe comes with some advanced management tools for being able to manage users and posts. You can invite users and specify the root directory that their account is able to access, as well as manage content that gets posted to any of your social media accounts, as well as your YouTube, your Twitter, and any other additional integrations that you configure for your specific account. Those integrations make their way into our integration marketplace, where you can select them and drive new connections, as well as ingest new data that, if Drainpipe does not currently understand what it is, you can visualize it and label it from within your artifact inspector. So let's check out some more assets. Within your asset manager, you can work with your multimedia and do things like redact certain sensitive information. So here we're going to apply a redaction. Let's go ahead and redact. So there we have a redaction that was made. And you can also apply additional annotations. You can set specific keywords for multimedia. You can convert multimedia. You can cut videos and apply advanced multimedia editing. Now, as you're using additional simulated environments, you can take the trained models that were created, such as the defect model that we created here moments ago, and you can also run them on your synthetic environments to better train and to better collect analytics that will help test and evaluate the performance of your models. So let's come to view here. So here's the data that we trained. And here we have our model and our dyno reports. And Drainpipe makes it as easy as just dragging the data over that you'd like to have as inputs and outputs for your model, and then clicking add and viewing the dyno reports as a result. So that's how you create a synthetic environment within Drainpipe. Drainpipe makes it very easy to be able to connect various forms of multimedia, visualize it, and train and test artificial intelligence models with it. I hope you enjoyed this demonstration. Please feel free to stop by our booth at the World AI Con Festival. We're at booth A08. We'd be happy to show you a more in-depth demonstration, and we also have some other examples that are currently running in our booth. Thank you again.